There's something moving through the darkness of space right now, something that arrived from beyond the boundaries of our solar system, something that shouldn't be here, and as it races towards Earth, it's doing something that has left the world's greatest astronomers, astrophysicists, and planetary scientists completely bewildered. Its name is 3I Beta/Atlas. And what makes this object so extraordinary isn't just that it exists, it's what's happening to it as it approaches us. Imagine, if you will, the universe as a vast ocean, and Earth, our little blue marble suspended in the void, as a single grain of sand on an incomprehensibly vast beach. The odds of anything from the depths of that cosmic ocean washing up to our shore are almost impossibly small. But every once in a while, something defies those odds. Every once in a while, something arrives, and when it does, we pay attention. Interstellar objects are rare. They're the universe's way of reminding us that we're not alone out here, that somewhere in another star system, other worlds are birthing their own planetary systems, scattering debris across the galactic void. Some of that debris, by the most improbable stroke of cosmic chance, finds its way to us. It travels through the darkness for millions of years, perhaps billions, before finally crossing the threshold into our solar system. We've only definitively identified a handful of such visitors. There was Oumuamua, then came Comet Borisov, and now there is 3I Beta/Atlas. But 3I Beta/Atlas isn't like the others. When astronomers first spotted it, they knew immediately that this was something extraordinary. The object was brightening, it was intensifying, its luminosity was increasing dramatically as it moved through space. And that's the problem. That shouldn't happen. And yet it is happening, and nobody can adequately explain why. Let me back up for a moment and help you understand why this matters. In the year 2017, we detected an object moving through our solar system at tremendous speed. It came from the direction of the star Vega. It was traveling at such velocity that the sun's gravity couldn't possibly capture it. This object would pass through our solar system and disappear back into the interstellar void, never to return. We called it Oumuamua. The name means messenger from afar in Hawaiian, and it was indeed a messenger from another star system, another world entirely.
Oumuamua was unusual in nearly every way we could measure it. It was elongated, cigar-shaped, we said. It had an unusual trajectory that suggested it was being influenced by forces we couldn't quite identify. And when astronomers looked at it through their telescopes, it reflected light in ways that didn't match what we knew about conventional comets or asteroids. There was something about Oumuamua that was fundamentally different enough that some scientists began to wonder, could this be artificial? Could this be a probe, a spacecraft, something sent deliberately to our solar system? These questions captured the public imagination. Books were written, documentaries were filmed, scientists debated passionately about the nature of this mysterious visitor. But ultimately, Oumuamua's most intriguing secrets would remain locked away as it flew past Earth and continued its journey into the cosmic void. Then came Comet Borisov. Discovered in 2019, Borisov appeared to be a more conventional interstellar object. It looked like a comet, at least in the traditional sense. It had a tail. It brightened and dimmed in patterns that seemed more predictable, more understandable. And while scientists remained intrigued by this visitor from another star system, Borisov never quite achieved the level of cultural fascination that Oumuamua had generated. But then came 3I-Atlas. A discovery occurred through the Asteroid Terrestrial Impact Last Alert System, ATLAS, a network of robotic telescopes designed to scan the skies for near-Earth objects. The system uses automated algorithms to identify moving points of light, to track them across nights of observation, to predict their trajectories and assess their significance. It's not glamorous work. Most nights, Atlas finds nothing of particular interest. It catalogs asteroids that have been known for centuries, monitors the trajectories of space debris, watches for anything that might pose a threat to Earth. But on the night 3I Atlas was discovered, the algorithms pinged. They had found something unusual, a point of light that didn't match known objects, a point of light moving through space in a way that suggested it wasn't bound to our sun, a point of light that bore all the hallmarks of an interstellar visitor. The initial observations were routine enough. Astronomers around the world turned their instruments toward the coordinates provided by Atlas. They began collecting data. They began building a profile of this mysterious object. What they were seeing, however, began to puzzle them almost immediately. The object was brightening. Now, you might think this is normal. Many comets brighten as they approach the sun. As they travel through space, they pick up solar radiation. The heat causes volatile compounds frozen within their structure to evaporate. This releases dust and gas, creating the characteristic coma and tail that we associate with comets. The increase in brightness is a natural consequence of this outgassing. It's chemistry, it's physics, it's predictable and well understood.
But 3I/Atlas wasn't just brightening. It was brightening in ways that violated the mathematical models astronomers have developed over centuries of observation. The rate of increase in brightness was too rapid. The intensity of the outgassing seemed too extreme. And when scientists looked at the spectroscopic data, the light signature that tells us what chemical elements are present in the object, they found something that made their eyebrows furrow. The composition suggested something unexpected. The ratio of different elements, the way light was being emitted, the patterns in the spectral lines, all of it pointed to something that didn't fit the traditional picture of a comet or an asteroid. We don't see this very often, one researcher told a colleague. And in the academic world, when someone says you don't see something very often, what they really mean is, we don't understand this. As 3I/Atlas continued its approach toward our solar system, astronomers made a decision. This object deserved closer attention. This object deserved more scrutiny. And so observatories around the world focused their instruments on this mysterious visitor. Massive telescopes on Earth aimed upward through the atmosphere. Space-based observatories, freed from the distorting effects of Earth's air, turned their unblinking eyes toward 3I/Atlas. Data streamed in, measurements were taken, and with each new observation, the mystery only seemed to deepen. Here's where we need to pause and think about what we actually know about comets and asteroids. These objects are the remnants of planetary formation. When stars are born, they're surrounded by disks of dust and gas. Over millions of years, this material collides and combines, gradually building up larger and larger chunks of rock and ice. Eventually, through this process of accretion, planets emerge. But not all the material becomes part of a planet. Some of it remains scattered throughout the system. Some of it collects in regions far from the star, in what we call the Oort cloud, a vast spherical shell of icy bodies surrounding our solar system, or in the Kuiper belt, a flatter disk of icy objects beyond Neptune's orbit. Every so often, gravitational perturbations nudge one of these icy bodies. A nearby star passes through the galaxy. Gravitational waves from merging black holes, billions of light-years away, create subtle ripples in the fabric of space-time. A wandering rogue planet, ejected from another solar system, passes through the galactic neighborhood. These cosmic nudges can send objects toward the inner solar system, where the sun's heat begins to affect them. But here's the key insight. We understand these processes. We've been studying comets for centuries. We have mathematical models that describe their behavior. When we observe a comet, we can predict its future brightness. We can estimate the composition of its nucleus. We can forecast when and where we'll see its tail. This understanding comes from thousands of observations, from centuries of accumulated knowledge. 3I/Atlas, however, was making predictions increasingly difficult. As the object drew closer to the inner solar system, the brightening accelerated, not just linearly, but superlinearly. The rate of increase was itself increasing. Astronomers who specialized in cometary behavior looked at the data and began talking among themselves in hushed, urgent tones. This is anomalous, they would say, using the careful language of science, which translated into plain English means, this shouldn't be happening. We don't know what's causing this. There were several competing hypotheses. The first and most obvious explanation was that 3I/Atlas was simply a very active comet. Perhaps it had an unusual composition. Perhaps it had been traveling through space for billions of years, and this approach to the sun was the first time in eons that solar heat was acting upon it. Perhaps the combination of extreme volatility and the object's unusual structure meant that outgassing was occurring at rates that simply hadn't been documented before. It was a reasonable hypothesis. Science often works by extending current understanding to new extremes. But as more data came in, even this explanation began to strain under the weight of observation. The second hypothesis involved rotational instability. Objects in space spin. They rotate around their axes, sometimes slowly, sometimes rapidly. In some cases, when an object has an irregular shape, changes in how it rotates can cause dramatic changes in how much of its surface is illuminated by the sun and how much of that sunlight is reflected back to us. Imagine a highly reflective, irregularly shaped object spinning through space. As it rotates, you might see dramatic fluctuations in brightness that have nothing to do with outgassing or any chemical process. They're purely geometric, a function of the object's shape and orientation. Perhaps, the thinking went, Atlas is spinning in an unusual way. Perhaps its rotation is causing these brightness variations. But again, when scientists applied their mathematical models to test this hypothesis, the numbers didn't work out quite right. The brightness changes were too extreme. They were too rapid. They seemed to follow patterns that couldn't be easily explained by simple rotational dynamics. Then there was a third hypothesis, one that was whispered about in conference halls and late-night online forums where astronomers gather. What if 3I-ATAS was fragmenting? What if the object was literally breaking apart? This is not unprecedented in cometary science. Comets can shatter. The stresses caused by solar heating, combined with the gravitational influence of the sun and planets, can be enough to break apart a weakly held together chunk of rock and ice. When this happens, suddenly you have multiple objects where once there was one. Each fragment continues on its own trajectory, but collectively they can appear far brighter than they would have before fragmentation. One of the most famous examples of this occurred in 1992 when comet Shoemaker-Levy 9 was torn apart by Jupiter's tidal forces. The comet fragmented into at least 21 pieces. Astronomers watched as each fragment approached Jupiter. In July 1994, the pieces collided with Jupiter's atmosphere in a spectacular series of impacts. The explosions were tremendous. Atmospheric disturbances persisted for weeks. It was a rare opportunity to witness the consequences of a cosmic collision. Maybe, scientists suggested, 3I-ATAS is experiencing something similar. Maybe gravitational forces are beginning to tear it apart. And yet, when the data was examined closely, the pattern of brightness change didn't precisely match what fragmentation would predict either. This is when things began to get genuinely strange. In the months following the initial discovery, professional astronomers and keen amateur observers became increasingly focused on 3I-ATAS. Telescopes across the Earth and in orbit above it were trained on the object. Data poured in, and with each new observation, the pattern became clearer and more inexplicable. The brightness wasn't just increasing, it was pulsating. There were periods where the object would brighten dramatically. Then, equally dramatically, it would dim. Then it would brighten again. The rhythm was almost like a heartbeat, like the object was alive somehow in a cosmic sense. Not alive in the biological meaning of the word, of course. Nothing alive in any conventional sense could survive in the depths of space, traveling between star systems. But alive in the sense that it was dynamic. It was changing in ways that violated expectations. Spectroscopic data revealed something even more curious. During the periods when 3I-ATAS brightened most intensely, the chemical signature changed. New elements seemed to appear. Old elements seemed to vanish. It was as if the object's composition was in flux, constantly changing, constantly shifting. One team of researchers proposed that what they were witnessing was a chain reaction. Perhaps some exotic chemical compound present in 3I-ATAS had been exposed to solar radiation for the first time in billions of years. Perhaps this exposure had triggered a series of reactions that fed on themselves. Perhaps these reactions were generating heat and light as byproducts, and the heat was accelerating further reactions. This would explain the self-reinforcing pattern of brightening. This would explain why the object was becoming increasingly energetic.
But exotic chemical compounds that reacted with sunlight in such a manner would burn out eventually. Their fuel would exhaust. The reactions would cease. Yet 3I-ATLS continued to pulse. It continued to brighten. It continued to confound the mathematical models. Then came the observations that truly shook the astronomical community. Using spectroscopy, researchers noticed something that at first seemed almost impossible. The object appeared to be emitting radiation across multiple wavelengths, not just visible light, but also ultraviolet radiation and infrared radiation. This suggested that the object wasn't just reflecting sunlight, it was generating its own light. It was producing energy through some process that was occurring within or upon its surface. Let that sink in for a moment. An interstellar object from another solar system, traveling through the void, was somehow producing its own energy. It was radiating light into the darkness, and nobody could explain why. The scientific establishment, always cautious, began to speak in measured tones about anomalies and unusual phenomena. Behind closed doors, however, conversations were more animated. In private emails and video conferences, scientists were asking questions that only a few years earlier might have been dismissed as the province of science fiction writers rather than serious researchers. Could this, one renowned astrophysicist asked, be related to some kind of technological activity? Could we be looking at something that isn't natural? The hypothesis was immediately cautioned against. The burden of proof for such an extraordinary claim is extraordinarily high, and rightfully so. The history of science is littered with examples of phenomena that seemed inexplicable until new understanding emerged. What appeared to be the work of intelligent beings was ultimately revealed to be a natural process that we simply hadn't understood yet. Pulsars, when first discovered, were thought by some to be potential signals from alien civilizations.
black holes seemed impossible. The Big Bang theory was initially rejected by many because it seemed to require something from nothing, which seemed philosophically unacceptable. And yet, the question had been asked, and once a question is asked in science, it cannot simply be unasked. It has to be investigated. Researchers began pulling together every piece of data they could find. They examined the object's trajectory with exquisite precision. They looked at the gravitational influences acting upon it. They tried to determine exactly where in interstellar space it had originated. If 3I-ATLS was artificial, if it was a probe or a spacecraft or some kind of technological artifact, then perhaps they could work backward through its trajectory to determine its origin point. Perhaps they could identify the star system from which it had been launched. The results were inconclusive. The object's origin appeared to be somewhere in the direction of the constellation Lyra, but the uncertainties in the calculations were large enough to encompass a vast region of space. There might be 100 star systems within the volume of space that could have launched 3I-ATLS toward our solar system. There might be 1,000. But here's what became clear as observations accumulated. Whatever 3I-ATLS was, it was definitely responding to its proximity to our Sun, and that response was accelerating as it drew closer. Let's think about what we're dealing with here from first principles. An object travels through space. It encounters gravitational forces. It encounters radiation. It encounters the solar wind, that stream of charged particles that flows outward from the Sun, carrying with it magnetic fields and energy. These are all natural processes that occur throughout the cosmos. We see them affecting natural objects, asteroids, comets, dust grains, constantly. But 3I-ATLS seemed to be responding to these forces in ways that were more dramatic, more energetic, more purposeful than we would expect from a natural object. Here's an analogy. Imagine you're watching the ocean. Waves roll in and out. The water rises and falls according to the tide. The current flows in its appointed direction. All of this is governed by physical laws, by gravity, by the rotation of the Earth, by the energy input from the Sun. It's predictable. It's understandable. But then something changes. The water begins to glow. Its temperature rises. It begins to roil and churn in ways that don't match any known oceanographic phenomenon. You look out at the water, and it's behaving as if some new force has been introduced, some new energy source, some new mechanism that you don't have a model for. That's what astronomers were seeing with 3I-ATLS. The object was behaving as if it were responding to forces that shouldn't be there. It was behaving as if it were active, as if something within it or upon it was responding to stimuli and taking action. The implications were too profound to ignore, and yet too extraordinary to accept without overwhelming evidence. The astronomical community found itself in an uncomfortable position. On one hand, the data seemed to suggest something that contradicted conventional understanding. On the other hand, the scientific method demanded that extraordinary claims require extraordinary evidence.
So researchers did what scientists have always done when faced with a puzzle. They worked the problem from every angle. They developed new models. They re-examined old assumptions. They looked for alternative explanations that might be more conventional, more comfortable, more likely. One hypothesis that gained traction involved the concept of metamorphic outbursts. Some comets, it was known, could experience sudden, dramatic increases in brightness. These were usually attributed to either rotational effects or sudden episodes of outgassing. But what if 3I-ATL was experiencing something even more extreme? What if the object had a structure that we didn't fully understand?
What if it had cavities within it that were suddenly opening up and releasing jets of material? This was possible. It was plausible. It fit within the framework of conventional cometary science. And yet, the more that researchers looked at the data, the more they had to acknowledge that this hypothesis, while not impossible, required a rather extraordinary set of circumstances. It required the object to have a very specific internal structure. It required that this structure have survived billions of years of exposure to cosmic radiation and the thermal extremes of interstellar space. It required that the object be oriented in a very particular way relative to the Sun. All of these things were possible individually, but taken together, the probability seemed low, very low. So we were back where we started, looking at an object that was behaving in ways we didn't fully understand. As 3I-ATL continued its approach toward Earth's solar system, the data continued to accumulate, and the pattern continued to become clearer and more anomalous. The object was accelerating its energy output. The pulsations were becoming more intense. The spectroscopic signatures were shifting in ways that defied easy categorization. It was as if 3I-ATL was warming up, as if something within it was being activated by its approach to the Sun. And then came the really shocking observation. A team of researchers, using advanced analysis techniques, detected what appeared to be structured patterns in the radiation being emitted by 3I-ATL. Not random fluctuations, not the chaotic outgassing of a natural comet, but patterns. Patterns that suggested, at least superficially, the kind of mathematical structure that might result from intentional signaling. Immediately, alarm bells began to sound. If this were true, if 3I-ATL were actually transmitting signals, then the implications would be absolutely staggering. We would be looking at the first confirmed evidence of extraterrestrial technology. We would be looking at something deliberately sent to our solar system by an intelligent civilization from another star. But the scientific community responded with both caution and skepticism. Other researchers quickly began to examine the data. They looked at the statistical properties of the supposed patterns, and they began to raise questions. Could these patterns simply be the result of natural noise in our instruments? Could they be artifacts introduced by our data processing? Could we simply be finding meaningful patterns because we're looking for them, a phenomenon known as pareidolia, the tendency of the human brain to see familiar patterns in random data?
These are crucial questions. They are questions that science must ask, because the history of astronomy is full of instances where researchers have misinterpreted data or made mistakes in analysis. The burden of proof for something as extraordinary as evidence of extraterrestrial technology must be extraordinarily high. And yet, the patterns persisted. Even after rigorous statistical analysis, even after multiple teams of researchers examined the data independently, the patterns remained. They were there, they were real, and they couldn't easily be dismissed as artifacts or noise. This is the situation that the astronomical community finds itself in today. We have an interstellar object that is behaving in anomalous ways. We have an object that appears to be producing its own energy. We have an object that is pulsating and brightening in patterns that violate our conventional models. And we have tantalizing hints that are suggestive but not conclusive that something intentional might be involved. So what are we dealing with here? What is 3I/Atlas really? Let's explore some of the possibilities. The first possibility is that 3I/Atlas is in fact a natural object,
a comet or asteroid from another solar system that is simply behaving in ways that we haven't adequately understood. This is the default assumption in science. The most likely explanation is usually the correct one, and our understanding of comets and asteroids, while sophisticated, is not complete. There may be phenomena occurring that we simply haven't accounted for in our models. There may be exotic chemical reactions or structural effects that produce the observations we're seeing. This is the explanation that most professional astronomers prefer, if they're being honest. It's comfortable. It fits within the established framework of science. It doesn't require us to completely revise our understanding of the universe. But as we've established, this explanation is having difficulty accounting for all the observed phenomena. The brightness changes are too rapid. The energy output is too intense. The spectroscopic signatures are too anomalous. The second possibility is that 3I/Atlas is a natural object, but one that possesses properties we didn't know natural objects could possess. Perhaps there's an entire category of interstellar objects that have structures and compositions far more exotic than we've realized. Perhaps these objects can generate energy through processes that are natural but simply unknown to us. This is also a possibility that science must take seriously. The universe is vast. The cosmos is diverse. Just because we haven't observed something before doesn't mean it can't exist. In fact, the discovery of new phenomena is one of the great joys of science. Every time we look at the universe with a new telescope or a new instrument, we discover things that surprise us. But the question then becomes, what natural processes could be generating the behavior we're observing? And that's the question that has stumped researchers so far. The third possibility, the one that keeps some scientists up at night, even though they won't often say it in public, is that we're looking at something artificial. We're looking at a technological artifact that was created by an intelligent civilization and sent through interstellar space to our solar system. Perhaps it's an unmanned probe. Perhaps it's some kind of beacon or signaling device. Perhaps it's something whose purpose we can't even imagine until we study it more closely. The evidence for this hypothesis is, at present, suggestive rather than conclusive. The apparent patterns in the radiation could be natural. The energy output could be explained through exotic but natural processes. The behavioral anomalies could result from structural or compositional properties we simply don't understand yet. But the patterns are there, and they're real, and they're difficult to dismiss. If 3I/Atlas is indeed artificial, what does that tell us? It tells us that at least one intelligent civilization exists somewhere in the galaxy. It tells us that this civilization possesses technology capable of sending objects across the vast distances between stars. It tells us that this civilization, at some point in the past, made the decision to send something toward our solar system. And it tells us that, whether intentionally or not, that something is now approaching Earth. Those are profound realizations. They touch on some of the deepest questions humanity has ever asked. Are we alone in the universe? How widespread is intelligent life? How does technology look when civilizations have advanced to the point where they can send probes across light years? If 3I/Atlas is indeed artificial, then we need to ask another crucial question. When was it sent? How long has it been traveling? If it originated from a star system 10 light-years away, then it's been traveling at least 10 years. But it could have been traveling for much longer. A sufficiently advanced civilization might routinely send probes that take centuries or millennia to reach their destinations. They might launch them as a matter of course, seeding the galaxy with scientific instruments and monitoring devices.
If this is the case, then the approach of 3i/Atlas to our solar system is almost certainly not directed at us specifically. It's not a message aimed at humanity. It's not a threat. It's simply what it is, a probe, an instrument, something sent to gather data or to transmit signals across the void. But even if that's the case, its presence would be revolutionary, for it would mean that we are not alone. It would mean that intelligent life is not limited to Earth. It would mean that the universe, this vast cosmos that we've been learning about for centuries, is inhabited by other minds, other intelligences, other civilizations. That would change everything. It would change how we see ourselves. It would change how we see our place in the cosmos. It would change our philosophy, our religion, our culture, our understanding of what it means to be human. And so the data continues to flow in, and so the mystery of 3i/Atlas continues to deepen. Let's consider what happens next. 3i/Atlas is approaching our solar system. It's getting closer. The brightness is increasing. The energy output is accelerating. The pulsations are becoming more intense. What will happen when the object reaches its closest approach to Earth? One possibility is that it will simply pass by, like Oumuamua before it. It will skim through the inner solar system. It will reach perihelion, its closest approach to the Sun, and then, like a comet deflected by the gravity well, it will swing back outward and continue its journey into the depths of space. After a few years or decades, it will disappear from our view, its light becoming too faint for our telescopes to detect, and it will rejoin the cosmic void from which it came. But what if it doesn't? What if 3i/Atlas is in the solar system not by accident, but by design? What if it's been aimed at us deliberately? What if it's a probe that's designed to enter our solar system, to study it, to gather data about us? This raises interesting questions. If such a probe reached our solar system, would it pose any danger to Earth? Almost certainly not. The distances involved in space are so vast that even a direct collision with Earth would be extraordinarily unlikely. The object would have to be aimed with absurd precision to hit our planet. Even if it did enter the solar system deliberately, it could observe us from vast distances away. It could gather data about our star, our planets, the chemical composition of our atmosphere, the presence of technological activity on our world, all without ever approaching Earth itself. In fact, the most probable scenario is that if 3i/Atlas were artificial, if it were deliberately sent to our solar system, it would likely maintain a significant distance from Earth. Any civilization sufficiently advanced to send probes across interstellar space would presumably also be sufficiently cautious to avoid causing alarm or disruption. But again, this is all speculation. This is all hypothesizing about what might be. The reality is that we don't know what 3i/Atlas is. We don't know why it's behaving the way it is. We don't know what the future will hold. What we do know is that it's approaching. We know that it's changing. We know that it's violating our expectations. And we know that as it continues to approach, we'll learn more about it. The scientific community is preparing. Telescopes are being positioned. Observatories are being alerted. When 3i/Atlas reaches its closest approach to Earth, when it's within the inner solar system, the eyes of humanity will be upon it. We will study it with every instrument at our disposal. We will collect data at resolutions far finer than we've been able to achieve so far. And we will do our best to finally understand what this mysterious visitor really is. There's something profound about this moment. There's something that touches something deep within the human spirit. Because for all of recorded history, humanity has looked up at the stars and wondered, are we alone?
We've asked that question in churches and temples and mosques. We've asked it in laboratories and observatories. We've asked it in philosophy and in science. And for all of history, we've had no definitive answer. But now, perhaps we might be on the verge of getting one. Not in the form of a radio signal, not in the form of a message beamed across the stars, but in the form of something arriving at our doorstep, something physical, something real, something that we can study and examine and understand. 3i/Atlas represents a turning point. Whether it's a natural phenomenon or something more, it represents the frontier of our understanding. It represents the mystery that still remains even after centuries of scientific advancement. It represents the fact that the universe, despite all we've learned about it, still has the capacity to surprise us. And as this object continues its approach, as it brightens and pulses and radiates energy into the darkness, it carries with it a profound message. That message is this: the universe is far stranger, far more complex, far more wondrous than we sometimes allow ourselves to believe. There are still mysteries out there. There are still questions without answers. There are still phenomena that defy our current understanding.
That's not something to fear, that's something to celebrate, because it's the existence of these mysteries that drives science forward. It's the unknown that motivates us to build better telescopes, to develop better theories, to ask better questions. It's objects like 3i/Atlas that remind us why we look up at the sky in the first place. Now, let's think about what all of this means from a broader perspective. For centuries, humans have imagined what it would be like if we encountered evidence of extraterrestrial life. We've written novels about it, we've made films about it, we've debated it endlessly in academic circles and in casual conversation. And in almost all of these imaginings, we've envisioned some kind of direct contact, an alien ship arriving in Earth's orbit, an alien message received through our radio telescopes, an alien probe landing on the surface of our planet. But what if first contact looks different than we imagined? What if it's not dramatic and sudden, but gradual and subtle? What if it comes in the form of an anomalous object whose nature we struggle to understand for years or decades? What if by the time we finally understand what 3i/Atlas is, by the time we've subjected it to intense scientific scrutiny, we've already begun to change as a civilization? That might actually be a blessing. A sudden, unambiguous encounter with extraterrestrial technology could be destabilizing. It could cause social upheaval, religious crisis, psychological distress. Humanity might not be ready for such a revelation. But a gradual, carefully studied encounter, one that happens over years, one that we examine with scientific rigor, one that we can discuss and debate and incorporate into our understanding at our own pace, might be exactly what we need. In this scenario, 3i/Atlas serves as a kind of messenger without being a messenger. It doesn't send a message through its radiation or its structure, but its mere presence, its mere existence is a message. That message is, you are not alone. And what more important message could anything deliver? Let's consider, too, the technological implications. If 3i/Atlas is artificial, if it is indeed a probe or some kind of technological device, then studying it would give us unprecedented insights into technological civilizations. We could learn about construction methods used by an alien species. We could learn about materials that are exotic or unfamiliar to us. We could learn about propulsion systems. We could learn about energy generation. We could learn about the very nature of how advanced civilizations think about space travel and exploration. Even if the object were completely non-functional by the time we retrieved it, even if it were damaged or degraded by billions of years of travel through space, it would still be an invaluable artifact. It would be like discovering an ancient spaceship. It would be like archaeology on a cosmic scale.
And think about what that would mean for humanity's future. If we could reverse engineer even a fraction of the technology inherent in an interstellar probe, the applications could be revolutionary. We might gain insights into propulsion systems far more efficient than our current rockets. We might learn about energy generation methods that could revolutionize energy production on Earth. We might discover materials with properties that would transform our technology. But of course, all of this assumes that 3I/Atlas is artificial, and that remains unproven. That remains uncertain. And that's the beautiful thing about science. It's the uncertainty, it's the mystery, it's the fact that we don't know. And we won't know for certain until we study this object more closely, until we can examine it directly, perhaps even send a spacecraft to intercept it, until we can analyze its composition, its structure, its origin. And that raises an interesting question. Should humanity send a mission to 3I/Atlas? The idea has certainly been discussed. The notion of launching a spacecraft, an unmanned probe most likely, to intercept 3I/Atlas and study it up close has been floated in scientific circles. It would be the ultimate research mission. It would allow us to gather data about this mysterious object in ways that are impossible from Earth. But there are challenges. The first is practical. 3I/Atlas is moving at tremendous speed. It's traveling fast enough that catching up to it would require a spacecraft capable of achieving speeds that, with our current technology, are difficult or impossible to attain. Our fastest spacecraft, the Parker Solar Probe, travels at speeds of around 650,000 kilometers per hour, about 0.06% of the speed of light. To intercept an interstellar object traveling at multiple tens of kilometers per second would require spacecraft with capabilities far beyond what we currently possess. But that's not an insurmountable obstacle. Technology evolves. Within decades, perhaps within centuries, we might develop spacecraft capable of achieving the speeds necessary to catch interstellar objects. The question then becomes one of priority and resources. Is it worth the investment to develop such technology? Is it worth the vast expenditure of resources to send a probe to intercept 3I/Atlas? From a scientific standpoint, the answer is almost certainly yes. The value of first-hand knowledge about an interstellar object, especially one that's behaving anomalously, would be immense. It would justify significant investment. But there's a second challenge, one that's more philosophical. Should we even try to intercept 3I/Atlas? If it's artificial, if it is indeed a probe or some kind of technological device, then do we have the right to examine it? Do we have the right to interfere with it?
These questions venture into the realm of space law and international relations, and they're questions that humanity will have to grapple with more and more as our exploration of space expands. But they're also questions that assume 3I/Atlas is artificial, and again, we don't know that. The most probable scenario, statistically, is that 3I/Atlas is a natural object, a comet, an asteroid, something made of rock and ice and dust, something that has been wandering through interstellar space for billions of years. But it's the probability that's the issue, isn't it? Because while it's more probable that 3I/Atlas is natural, it's not overwhelmingly probable. It's not certain. There remains a possibility, a real possibility, however small, that we're looking at something artificial. And in the face of that possibility, the entire calculus of humanity's future changes. Let's zoom out for a moment and think about the bigger picture. The existence of 3I/Atlas, whether it's natural or artificial, tells us something important about the universe. It tells us that the universe is a dynamic place. It's a place where objects move between stars. It's a place where exotic phenomena occur. It's a place that's constantly surprising us, constantly revealing new mysteries, constantly challenging our understanding.
This is important because it combats a tendency humans have, a tendency to assume that what we know is complete, to assume that we've figured things out, to assume that the universe is, in most respects, understood and categorized and sorted into neat boxes labeled known. But 3I-Atlas reminds us that this isn't the case. 3I-Atlas reminds us that there's still so much we don't know, still so much we don't understand, still so much mystery left in the cosmos. And that's beautiful, because mystery is the font from which all scientific progress flows. If there were no mysteries, there would be no motivation to conduct research. There would be no reason to build telescopes or spacecraft or observatories. We would stagnate. But 3I-Atlas, this strange, anomalous, inexplicable object hurtling through space, keeps us asking questions. It keeps us reaching for answers. It keeps us engaged with the cosmos in a way that's both intellectual and emotional. There's something almost poetic about it, really. An object from another solar system, possibly created by an intelligence we've never encountered, possibly carrying signals we don't understand, approaching our solar system. The universe sending us a gift, or a puzzle, or a message written in a language we don't yet speak. And we stand at our telescopes, our instruments, our satellite observatories, and we try to read that message. We try to decode it. We try to understand it. And in trying to understand this one object, we learn about ourselves. We learn about our own nature. We learn about our place in the cosmos. This is what science is, really. It's not just about collecting data or building theories or making predictions. It's about the eternal human quest to understand the universe we live in. It's about standing up and asking, what is this? Why is it like this? What does it mean? And when an object like 3I-Atlas appears, we get to ask those questions on the grandest scale. So as 3I-Atlas continues its approach, as it brightens and pulses and radiates its mysterious energy into the darkness, let's appreciate what we're witnessing. We're witnessing one of the great mysteries of our age. We're witnessing the frontier of human understanding. We're witnessing a moment that will, decades and centuries from now, be remembered as pivotal, as important, as the moment when humanity encountered the unknown and had to decide how to respond. And the response has to be curiosity. It has to be a commitment to understanding. It has to be the scientific method applied with rigor and dedication and passion. Because whatever 3I-Atlas is, whatever it's doing, we need to understand it. We need to study it. We need to learn from it. Because the universe is speaking to us. Through this object, through this mysterious visitor from another star, the cosmos is sending us a message. And that message is this: there's so much more out there than you've imagined. There's so much mystery. There's so much wonder. There's still so much to learn, still to discover, still to understand. And we should embrace that. We should celebrate it. Because a universe full of mystery is a universe worth exploring. 3I-Atlas is approaching. The countdown has begun, and humanity waits, watches, and wonders what will happen next. Will it prove to be a natural phenomenon that finally yields its secrets to scientific inquiry? Or will it be something more? Something that forces us to completely reconsider our place in the cosmos? Will it be a messenger from an alien civilization, a probe sent across light years to study us as we study it? We don't know. We won't know until more data comes in, until the object draws closer, until we can examine it with more sophisticated instruments and more advanced techniques. But the not knowing That's where the excitement lies. That's where the mystery lives. That's where science meets wonder and discovery waits at the edge of understanding.
So watch the skies. Keep your eyes on the data streams coming from our observatories and telescopes. Pay attention to the announcements from the astronomical community, because 3I Atlas is out there. It's real, it's approaching, and it's rewriting the rules of what we think we know about the universe. The story of 3I Atlas is just beginning, and we're all characters in it now. We're all part of this grand adventure, this cosmic mystery, this eternal human quest to understand the universe we inhabit. What will we learn? What will we discover? What will this strange visitor from the depths of space teach us about ourselves, about our universe, about the possibilities that exist in the cosmos? Only time will tell, but one thing is certain. The age of interstellar contact has begun. Whether 3I Atlas proves to be natural or artificial, whether it answers our questions or raises new ones, it has changed us. It has reminded us that we are not alone in contemplating the cosmos. It has shown us that the universe is far stranger, far more wonderful, far more full of possibility than we sometimes allow ourselves to believe. And that, perhaps, is the greatest message of all.